Hi everyone, I'm Valerie Hagger. I'm a researcher at the University of Queensland focused on coastal wetland conservation and restoration. And this is a brief presentation of work we've been doing on how to assess and monitor biodiversity in coastal wetland restoration. So I just wanted to start by explaining what is restoration success. So this is related to what you are trying to achieve or your desired outcomes from restoration. And in coastal wetlands, there are lots of different reasons why people undertake restoration: to store blue carbon, to recover biodiversity, to support fisheries, and to improve water quality, for example. And under the Global Biodiversity Framework Target 2, this is to enhance biodiversity and ecosystem function and services and enhance ecological integrity and connectivity. And this is a project which I've been doing to develop a framework to identify restoration sites for coastal wetlands under blue carbon. And it's an approach to select sites across a region that are both biophysically suitable and also economically feasible for blue carbon, and also recognize the number of benefits or co-benefits that those blue carbon restoration projects can provide for biodiversity, fisheries, water quality, specifically removal of dissolved inorganic nitrogen, and coastal protection in regards to flood mitigation. So it's to identify sites which are both economically feasible for blue carbon and also maximize the delivery of these co-benefits. And what we've done is that we've developed indicators for these co-benefits based on scientific knowledge and data availability. But these measures and indicators can change across the regions depending on the data availability and the specific characteristics of the regions. And this paper has just been accepted for publication in Journal of Environmental Management, so hopefully I can share soon. And I wasn't going to go into detail about how we measured the other ecosystem services, only to explain what we did for biodiversity. So for biodiversity, it was about assessing the potential biodiversity value of that restoration site, and then being able to rank those sites based on the biodiversity value. So we focused on the ability of that restoration to benefit threatened and migratory species. So this was based on the number of records of threatened and migratory species under a 1 kilometre buffer of the restoration site from verified records in state wildlife databases. Then we also assess the potential habitat for a focal threatened species in the restoration site based on modelling of habitat that is likely to be restored at the site and known habitat preferences and locations of the species. We also considered connectivity to existing wetlands, both internationally recognised Ramsar wetlands and also existing wetlands which are mapped as palustrine, estuarine or marine. And there are a number of frameworks for successful restoration. So the Society for Ecological Restoration have the recovery wheel, and they list a number of ecological attributes that should be used in planning a restoration project and monitoring that. These are on species composition, structural diversity, ecosystem function, external exchanges, absence of threats, and physical conditions. We've also recently released the best practice guidelines for mangrove restoration. So specifically for planning and implementing mangrove restoration, to improve success, you should be establishing clear goals and measurable objectives using quantifiable indicators. You should ensure that your restoration is feasible and you have the community engaged. You need to consider the landscape and the changing climate. You should be addressing biophysical challenges and socioeconomic issues. And we suggest following the restoration continuum, so using nature to initiate restoration, so using assisted natural regeneration like tidal reintroduction rather than active planting, and also to monitor for adaptive management. So this starts and ends with indicators to track progress. So we need indicators which are relevant, quantifiable, and have an acceptable degree of confidence. And we identified that there are important parameters for monitoring mangrove restoration, and these are hydrological connectivity, biophysical conditions, structural diversity, threats, and biodiversity. But in some other work we've been doing in looking at what is the opportunity for using remote sensing in monitoring coastal and marine restoration, we found that in most cases, remote sensing is only being used to measure the extent of ecosystems, what the condition of the ecosystem is using vegetation metrics like NDVI or EVI. It can also be used to measure biophysical attributes like turbidity or elevation or bathymetry, and it can measure some threats like land use change. But what is missing is the ability to measure biodiversity. So it can be used to measure species composition, but this is more emerging. But regardless of the method you use to monitor restoration, whether it's remote or field-based data, you should have a good approach to monitor that. So BACRI is your best, your gold standard to monitor restoration projects. So this is before, after, control, reference, impact. And there are essentially three approaches to monitor restoration projects. The first is just to have any improvement from a baseline or before restoration, and there are standards suggesting which this is acceptable because there are issues with assessing control sites and even having control sites available. But I would suggest that this is not sufficient and that at a minimum we should be tracking progress relative to the reference state or a native ecosystem. And as a gold standard, we could also assess progress relative to an unmodified control or a counterfactual with no restoration. And this is suggested to evaluate the benefit of restoration. And I've also been developing a method or an approach to measure biodiversity in coastal wetland restoration to try and standardize the way we measure biodiversity, because there's lots of different ways you can measure biodiversity in coastal wetlands. And this method has been focused on measuring vegetation and habitat characteristics that reflect restoration trajectory and habitat condition, and then 3 selected taxa of fauna diversity, which are integral to coastal wetland ecosystem function at different trophic levels. So this is benthic macroinvertebrates, bird communities, and bats. So in summary, remote data can be used to assess sites for likely biodiversity values, to avoid trade-offs and prioritize sites. And in monitoring, remote data can be used to assess some ecological attributes that are recommended in the SIR recovery wheel. For example, the extent of ecosystem, like the percent cover, the condition of that ecosystem, whether it's degraded, the physical attributes, which could be used to evaluate restoration success, and also some of the key threats. But assessment and verification of biodiversity will also require field-based data. So really, we need a combination of remote and field data to monitor and evaluate restoration outcomes. And therefore, for monitoring area under effective restoration, we need a framework which encompasses both remote and field data. And importantly, restoration projects should assess reference sites to define benchmarks for indicators. Thanks very much.